Hi guys, this is AAT section 2.4 graphing piecewise functions. A piecewise function is a function defined by at least two equations or pieces, each of which applies to a different part of the domain. So a piecewise function looks like this. So you have your f of x equals each different part of the graph for these different x values. Please fix your notes. Little typo, these should be -3s, not -1s. And over here, not -2s, change those to -3s. So what this means is notice that the changes focus around the values of -3 and 1. When x is less than -3, we're going to have this graph. So the graph is just a line. We know that's in y equals mx plus b form. It has a slope of 1 and a y-intercept of 3. But only for x values less than -3. For when x is between -3 and 1, you're going to get y equals, or f of x equals 1, which we know is just a horizontal line. It's a constant horizontal line with a zero slope. Y equals a number. And when x is greater than 1, the graph is quadratic, which is part of a parabola, because this is just then y equals x squared. So for the first part of the graph, for less than -3, if we graph that whole line, y equals x plus 3, and we know how to do that, we plot at 3, use the slope, up 1 over 1, but we're only going to use this piece of the graph. It's going to start, if I plug in -3, I think it's always really helpful to plug in what I call these border points. If I plug in -3, I'm going to get the point -3, 0. So -3, 0 is going to be my first point for that piece of the graph. If it's equal to, it's going to be a solid point. If it's not equal to, it'll be an open. So this is the first piece of my graph. Then in the middle, we go from -3 to 1, and it should be a constant. So again, if I plug in my border points, if I plug in -3, there's nothing to plug it in for, so I get 1. And if I plug in +1, I also get 1. So this graph should start at -3, 1, and I make it open because it's not equal to, and it ends at the point 1, 1, 1, 1, and it's an open point there too, because it's not equal to. So open point to open point, and I only graph that piece of that whole graph, y equals 1. And then for the third, that's a parabola. We know it's a parabola at the point 0, 0 for the vertex. We go up 1 and over 1 to get our next point, up 2 over 4 to get our point after that. But since it's just this piece, we plug in our border point of 1, and we get 1. So this part of the graph starts at 1, 1. It's equal to, so it's a solid point. And then we just graph the places that it's greater than 1. So now we're going to take each piece. We got this piece, solid point, slope of 1. We have this piece, the constant. And then we have this little piece of a parabola. And we put them all three together, and we get that piecewise function. So let's try some. So first, I can see that these are two lines that I'm going to do, both with a negative slope. So first thing I would do is plug in those border points. If I plug in 2 to the top, I get -4 minus 1 is -5. Just plugging in 2x, and I get -4 minus 1. If I plug in 2 to this part, I get 4 and a -2, which is a +2. So for this first graph, it's for x is less than 2. So 1, 2, we're only talking about, this isn't an asymptote, we're just talking about this part of the graph, less than 2. So this line is going to start at the point 2, -5. 1, 2, 1, 2, 3, 4, 5. It's a closed circle because it's equal to. So if it's equal to, make sure it's a closed circle. and then it has a slope of -2. Well, I also know that the y-intercept is -1, so I can go ahead and fill that in since that's on that part of the line. If I use a slope of -2, that's up 2, back 1, up 2. Uh-oh, I'm not hitting right. Did I count right? 1, 2, 3, 4, 5, up 2, 1, 2, back 1, up 2, 1, 2, back 1. That's right. 1, 2, back 1, and so forth. So here is this piece of that piecewise. And then I start for the next one at my border point, 2, 2, 2, 2. This one's open because it's not equal to. I have a y-intercept of 4, 1, 2, 3, 4, but I don't want to plot that point because I'm now graphing the part of the graph on this side that is greater than 2. So I'm not going to plot that y-intercept. I'm just going to start at my border point and use a slope of -1. So a slope of -1 is a line that's facing this direction, down 1 over 1, down 1 over 1. Think of the direction of your slopes for negative slope, which would look like that. And that's my piecewise function. Notice none of the graph is overlapping. For greater than 2, I'm at all these points. For less than 2, I'm at all these points. You shouldn't end up with not passing the vertical line test with one graph on top of the other. Okay, next one. Again, let's put it in our border points. Let's think of what we have. We have a line here with a slope of 1/2 and a y-intercept of -3. We have a constant horizontal line at -3 and another constant down here. So if we plug in our border point of -2, 1/2 times -2 minus 3, that would be -1 minus 3 is -4. If I plug in, I have 2 border points here. If I plug 0, I get -3. If I plug in 2, I get -3. Because everything I plug in here, I get -3. And for the last one, if I plug in 2, I get 3. So I want to start with less than -2. So -2, less than -2. So I want one graph all over here less than -2. So it should hit the point -2, 1, 2, 3, 4, -4. It is open because it is not equal to, it's just less than. It has a slope of 1/2. So let's think slope of 1/2 is up 1 over 2, up 1 over 2. But I don't want to go that way because the graph is less than -2. So I'm going to go down 1, back 2, down 1, back 2. A negative over a negative is the same as a positive slope. So there's that piece of the line, less than -2. Now I need to go from 0, -3, 0, -3, 1, 2, 3, and it's equal to, so it's a solid point, and to 2, -3, 1, 2, -3, and again solid because it's equal to at 2. And this is a constant, which is a horizontal line between 0 and 2. You should be equal to -3. And then for greater than 2, so this piece of the graph, greater than 2, I start at the point 2, 1, 2, 3. I'm going to make that open because it's not equal to, and it's a constant line for all points greater than 2. So there's my 3 pieces. Notice there's no graph between -2 and 0 because it was undefined, nothing defined between 0 and -2. None of the graphs overlap. At any given x value, if one point's closed, the other point better be opened. Okay, next one. This time we have a parabola and a line. So again, plug in the border points. At 1, I'm at 0 up here. At 1, I'm at 4 for this one. So let's start with the top one. 1, 0. I'm right here. Our dividing piece is at 1, so we're going to have a graph over here and another graph over here. This is a parabola. What's that vertex of that parabola? Remember our h and k, our vertex is 1 and 0. So this is our vertex. So if we were to graph the whole parabola, we go over 1 up a, over 2 up 4 times a, and we end up with it on both sides, and we'd end up with this whole parabola like this. But it's only defined for values greater than or equal to 1. So I'm only going to darken the part that's greater than or equal to 1, just that piece of the parabola. And I could erase that piece on the short side. Okay, and over here we got a line. It's going to start at the point 1, 1, 2, 3, 4. Open circle, it's not equal to. So the y-intercept's 3, but I don't want to plot, well, I do want to plot that this time because it is less than 1. Slope is 1, down 1, back 1, down 1, back 1. Make sure it's facing the way a positive slope should be. So there's that graph. Okay, and last one on this page. So this one has a lot of intervals going on. So I'm going to plug in all those border points. At -5, if I plug it in, I'm just going to get 0. At -2, I'm also going to get 0. So that's a constant horizontal line when y is 0. Here, if I plug in -2, I get -2 squared, which is 4. So -4, get -4 plus 4 is 0. If I plug in 1, I get -1 plus 4 is 5. And then here, if I plug in 2, a -2 and 3 is 1. If I plug in 5, -5 plus 3 is -2. So start at the top here. We're going from -2 and -5. So we want to graph between those places, -2 and 5. So this is a horizontal line from -5, 0 to -2, 0. The 5 is closed because it's equal to. The 2 is open. So that's that piece of the graph. This one's a parabola. We're going to start at the point -2, 0. So -2, 0. And so that point was open, but now it's closed. So I'm going to close it up. And then front to 1, 1, 2, 3, 4, 5. Okay, so I know it's a parabola, so I might just swing it in here, but let's make sure what the vertex is. The vertex of that parabola is 0, 4. Remember, what's with x is h and k. And this is a downward facing parabola. So 0, 1, 2, 3, 4. 1, 2, 3, 4 should be right there. Okay, so let me check. Did I plug everything in it incorrect? No, I didn't. If I plug in 1 here, I get -1 plus 4, which is 3. Hopefully y'all saw me make that mistake. So this point should actually be here. Okay, so I got my vertex of my parabola. Over 1, down 1, 1, 3, and -2, 0 should be the 2 points. So I swing in just that piece of the parabola. You can graph the whole thing if you want to and just erase it. That's easier, but it shouldn't go past x equals -2 or beyond x equals 1. Then the last one, this is a line with a slope of -1. So I'm going to hit the points, those border points 2, 1, 2, 1, and that is open at 2, and 5, -2, 1, 2, 3, 4, 5, -2, and that one is closed. It should be a line with a slope of -1, so down 1 over 1, down 1 over 1, down 1 over 1, so that looks right. So there's that line, and it stops there. Don't go past there. This graph does not go beyond 5 or less than -5, so there's no arrows on this graph like that one's. Okay, so we're going to stop right there and come back on the next video. I'd like you to go on to the next page and try this one on the top of the page, and then we will check it on the next video. Actually, go ahead and try both of them. Let's see how we did.